Modeling with formulas. I'm Anil Kumar, and in this example we are going to explore a very important formula relating time period of a pendulum. The question here is, the time period t in seconds of a pendulum is related to its length L in meters by the formula t equals to 2 pi square root L over G, where G equals to 9.8 meters per second square is a constant. Solve this formula for L and find the length needed for the pendulum to have a period of 1 second. So there are two parts to this question. First, we are given a formula which is t equals to 2 pi square root of L over G. So we need to isolate for L from this formula. And after that, we need to find length L of this pendulum so that the time period is 1 second. Now, time period really means that if you have a pendulum like this, time taken for one oscillation, that means kind of like this. Do you see that? So it'll go to one far end, from there to the other, and come back to its resting position. So that is one time period, time taken for one full cycle. Okay, to isolate for n, we need to first divide by 2 pi on both sides. So we get t over 2 pi equals to 2 pi square root of L over G. So we are dividing by 2 pi on both sides. Now 2 pi divided by 2 pi is 1, so we can write this as t over 2 pi equals to square root of L over G. Now we need to isolate for L, that means we can square both sides so that we get rid of the square root term. So if I square, I get t over 2 pi whole square equals to square root of L over G whole square. So here we get t square divided by 4 pi square equals to L over G. Now since we need L, we can multiply by G on both sides. So we get t square over 4 pi square times G equals to L over G times G, right? So let's go one more step here. G and G will cancel. That means G divided by G is 1, right? So what do we get? We get L equals to t square over 4 pi square times G. So that is how we can isolate for L. Looks complicated, right? Go through it once again. Try to understand all the steps. Now the question is, solve this formula for L, which we have done, and find the length needed for the pendulum to have a period of 1 second. That means t should be equal to 1. G is given to us as 9.8 meters per second square. Others are also constant, so we can substitute these values here and find L. So L is 1 square divided by 4 pi square, and G is 9.8, right? Now we can use calculator. So basically we have 9.8 over 4 pi square, correct? So let's use calculator to find the answer. So 9.8 divided by 4 is equal to something which will divide by pi square, and that is equals to, so we can write this answer, which is 0.2482, right? So that is what we get, and the length should be in meters, since G is in meters per second square, right? Time was in seconds, so second square cancels, you are left with meters, correct? So the length is 0.2482 meters, or you can say the length of the pendulum. So we can write down our answer, that the length of the pendulum is equals to 24.8 centimeters, right? So you can convert them to centimeters also and write it as 24.8 centimeters. So that is how you can find the length of a pendulum, which will give you a time period of 1 second, which is approximately 2 feet. I hope that helps. Thank you.